In this lecture, we're going to learn about math functions. And these are functions that are built into the C++ standard library that we can use to do some math. If you are doing some math operations, you're going to find these helpful. They live in the C math library, and if you want to use them, you're just going to include that and you're going to have access to them. What you see here is a simple summary of some of the things you can use in these math functions. You can use stdfloor to round down or stdceil to round up. You can use the abs function to compute the absolute value of a number. You can do trigonometry, you can do the cosine, sine, and things like that. You can compute the exponential of a number. You're going to see what this means in a few lectures. You can use stdlog. And again, if you have some math background, these concepts are not going to be foreign to you. Many of these functions are documented here at CPP reference, so it might be worthwhile to go there and check what functions are available there. Here is an example of something you might want to do. For example, you have a variable. It's called weight. Inside we have a 7.7. And if you do stdfloor of this variable, this is going to be rounded down to a 7. If you want to round up, you're going to use stdceil and you're going to get that. And we're going to see what this is going to give us in a minute when we hit Visual Studio Code. Here is how you would use the absolute value function. You have a few variables here, and if you try to plug them in, this absolute value function, you're basically going to get the weight of the number without any sign in front of the number, positive or negative. The absolute value is the weight of the number without caring about the sign, if I may say it like that. Okay, we also have the exp function, which is going to compute the exponential of a number. This is a math concept, so if you don't have a background in math, this is going to be a little hard to wrap your brains around. But in math, we have this number, which is called e, and its value is approximately 2.71828, like you see here. The exponential function is going to do what fx here is doing. It's going to take e and elevate that to the power of x. And for example, in our code here, we're going to get the exponential of 10, which is going to be e elevated to the power of 10. And we're going to play with this in Visual Studio Code, and you're going to see the value of this. We also have the power function here, which is going to take the first parameter and elevate that to the power of the second parameter. So this is going to be 3 to the power of 4 and 9 to the power of 3. And we're going to get the answer if we plug this into Visual Studio Code. And we have log functions, which is basically the reverse of the power function that we just looked at. If you do log 8 in base 2, for example, it is like you are asking, to which power should I elevate to so that I get 8? And the answer here is going to be a 3, of course. But the catch is that the log function by default works in base e. So what we are asking, for example, if we say log 54.59 is to which power should we elevate e to get this number in here? And it is going to be computed, and you're going to see this if you plug this into Visual Studio Code, or you can try to use one of the calculators available to you, and you're going to see that this makes sense. We also have a special function that is going to do the same thing, but in base 10, and this is going to be easier to understand. For example, here we are computing log 10. So what we are really saying is to which power should we elevate 10 to get 10,000? And this is easy because the answer is 4. 10 to the power of 4 is 10,000. I really hope this makes sense. We also have a square root function we can use. So square root of 81 is going to be 9. We have a function called stdround, which can round. And what it's going to do by default, halfway points are going to be rounded away from 0. So if you have a 2.5, it's going to be rounded up to a 3. And if you have 2.4, it's going to be rounded down to a 2. We also have a host of functions we can use in trigonometry. We have a sine function, we have a cosine function, we have a tan function. If you know these concepts in math, This is going to come in really handy if you want to do this. I have to say that what we just talked about is a small set of what we can do with these functions here in CMath. And we are here at cppreference.com, and we can see all these functions here. We can do reminder, we can do fmin, and if you want, you can check these out in the documentation. For example, if you go to tan here and click on it, you are going to get the description and explanation of what this function does, and you're going to have a simple example of how you can play with this. Okay, now I hope you have a better idea of what we can do with these functions in the CMath library. We're going to head to Visual Studio Code and play with some of these functions. Here we are in Visual Studio Code. The current project we're going to work on is math functions. We're going to copy over our template files, and we're going to put them in our directory here, math functions. And we are going to open this up in Visual Studio Code, and we are going to remove whatever it is we don't need, and we are going to include our library, which is CMath, and we are going to put in our code so that we can play with this. And here we have a variable called weight, and we're going to try and use a few math functions on it. So we can use stdfloor to round down and stdceil to round up. So weighted rounded to floor is going to be printed out, and weight rounded to ceil is going to be printed out. We're going to have a number here in this savings variable. It's going to be a negative number, and we're going to try and compute the absolute value of this. We're going to see it printed out. Another thing we're going to compute is the exponential of a value. We're going to do stdexp10. And what this is going to do is going to take e and raise it to the power of 10, and that's what we're going to get printed here. The other thing we want to do here is compute the power of a number. We're going to take 3 and raise it to the power of 4, and take 9 and raise it to the power of 3, and we're going to see what these things evaluate to. We're going to open up our terminal here, and we're going to run the task to build with GCC. The build is going to be good, and if we run Rooster, we're going to get these things here. So 7.7 rounded to floor is going to be 7, so we're going to round down. 7.7 rounded to ceil is going to be 8, and that's what we're going to get. And the absolute value of weight is going to be 7.7 because it is a positive number, and the absolute value of minus 5,000 is going to be 5,000. And again, when you compute the absolute value of something, you are interested in the weight of that thing without considering the sign, without really worrying if it is positive or negative. You just want to get the magnitude of a number. That's what we use in math to mean that. Magnitude. Okay, so if we go down, we're going to get the exponential of 10 is exponential, and you're going to get that here. And again, what this function does is take e and raise it to the power of 10, and that's the answer here. We can try and prove this with a calculator. So I am going to open my Windows calculator. You can use whatever calculator you have access to. I am going to use a scientific calculator here, and you see that we can hit E, and we're going to get the value of this E number in math. Here it is simplified, but if I take it and raise it to the power of 10, the answer is going to be 22.026. And if we look in our program, we have 22.026.5. Okay, it is rounded up a little bit, but it is almost the same thing. Okay, we also want to play with log functions a little bit. Log is basically the reverse of the power function. And we just talked about this in the slides, but if we do log 8 in base 2, we are basically asking to which power should we raise 2 to get an 8? And the answer to that is going to be what this log number in base number is going to evaluate to. The catch is that the log function, if you use it row like this, it is going to be using base e. And we just saw that e is 2 to the power of 7 or something. Let's go back to our calculator and see if we can see that. Why not? Why try to guess when we have a good calculator in our hands? We are using the scientific calculator. So if we hit e here, this is the value of e. Okay, so when we do log, we are basically asking to which power should we raise e so that we can get this 54.59. And the answer is going to be computed and printed out here. We have a version of this that is going to use base 10. So if we use this, we are basically saying to which power should we raise 10 to get 10,000, and the answer is going to be printed out here, and it is going to be a 4 because this is easy to do in your mind. So let's run this. We're going to build the task. We are going to run the task to build with GCC, and we're going to run our program, and we're going to get our output here. To get 54.59, you would elevate e to the power of this number here. This is the answer. And if you want, you can prove this with your favorite calculator. You're going to get something close to this. To get 10,000, you'd need to elevate 10 to the power of 4. That's what we're going to get in here. Let's print this out. Again, many mistakes. Sorry, but I hope you get the point. If we build again so that we can see things properly and run, we're going to get proper data. And this is really what we expected to get. We have a few more functions we can play with as we saw in our slides. Let's play with square root and the std round function. Here we are going to get the square root of 81. We're going to get it printed out, and we're going to see what std round does. It is going to round away from 0 if we are at half point, and if we are not at half point, if we are below that, we're going to round down. If we are higher than that, we're going to round up. We're going to run this so that you can see this running, and we're going to call rooster, and 2.5 is rounded to 3, 2.4 is rounded to 2, 3.6 is rounded to 4. This is what we expect, and the square root of 81 is 9. This is really all we set out to do in this lecture, to play with a few of these CMath functions. They are not really hard to use once you have the basics of math nailed down. And again, if you want to check the full list of these functions, please come to our reference documentation here. You're going to find a lot of them. And if you want to see how to use one of these, for example, if you click on log 10 here, you're going to come here, you're going to get an explanation of the function, and even better, you're going to go down and get a nice piece of code you can play with and really make sense of what is happening in these functions here. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about some weird integral types. Go ahead and finish up here and meet me there.